recording, and now I can really pretend like I know what I'm doing. So, hi, I'm Mac. Thanks for showing up and being interested enough to show up, and I hope you enjoy. Today I'm hoping to talk about web security and a little bit of the stuff that goes along with it. It's not going to be anything necessarily specific other than a little look into what HTTPS does, and even then not too much. It's more into the certificate infrastructure than anything, I guess. But yeah, so hopefully you already noticed when you're browsing the web whether or not the site that you go to says HTTPS on it, and whether you're at https.bankofamerica.com or whether you're at bankofamerica.com without the fancy lock and it saying not secure, hopefully, nowadays, and that you're using a good updated web browser because you're sane. And they all do that now except links, in which case you're not sane anyways. So what we're going to look really into, what does that kind of mean, how does a site get that, and how does that relate to other keys that servers might use or that we might use even. So to start looking at that, we kind of want to know what HTTP does. And HTTP is a protocol built on TCP, Transmission Control Protocol, that transmits most of the data on the internet. UDP is now a growing exception to that. But when you want to actually get data somewhere, TCP does it pretty well. So it goes and signals to a server, it creates a connection on that server with the SYN ACK. We can go and send a request to the server for getting an HTML file and the CSS and whatever else might be there. The server does some crap and tries to figure out what to do with its life, and then it goes and sends things back to us, and that can take a little bit of time. Oops, I did not want to go to the next slide. Hopefully then you get everything that you need and you can close the connection, or you leave the page, or maybe you just go to another page and have to ask the server for another thing. But that connection can stay open, which is mildly interesting, but not particularly helpful to us today. But one thing we don't notice in there is any encryption of any kind. So if you go and use something like Wireshark to capture this, you can go and look at that and say, well, wait a minute. There's the entire HTTP or HTML right in my browser. And it's the same plain text for anybody who's in range of my Wi-Fi network, anybody who's connected physically and or has hacked a router in between my computer and the world at large, or has gotten on that server but not necessarily is controlling the program yet. Right? If you can look at that data, you have a knowledge of what's going on there. There's not anything hidden to this at this point. It's merely a connection that sends back what it's asked for. And that's not good usually. Normally we'd like for most of our things to be a little bit secure. Otherwise we end up with our Bank of America thing that goes and gets hacked, and nobody likes that. Unless you're the one doing the hacking, in which case still you might not like that. If we want to look at HTTPS, there's a couple main things that go along with that. And the biggest of these is that you get an authentication of who the server is. And there's a lot of extra packets that get sent with this, and that's really not something that I'm particularly as much interested in. I'm much more interested personally in how we know who the server is. So you could go and look as much as you care at the Wireshark capture that I did upload for an HTTPS request to our server. And that, I believe, is called request or something on the Google Drive folder. I should actually look at the text chat, huh? Paged? What do you explain? I'm not sure what you mean there, Mickey. So, yeah. So what really makes it different, there's the two things to it. As I said, there's the certificate that helps us to prove who the server is, and that when I go and say that I'm connecting to Bank of America, alright, Kevin's, I guess, got it, that it is actually Bank of America. And the other part of it is that once I am connected to the server that I'm sure is Bank of America, that we can be certain that I have private communications to them. So we don't want to go and connect to Bob instead of Bank of America, and we don't want Bob to be able to listen to our conversation with Bank of America. So we want to be able to certify that who we're talking to and encrypt what we're talking and saying. If you were here for my RSA talk a couple quarters back, I kind of went into RSA cryptography and public key cryptography, but I know that quite a few of you weren't. Can I get like a poll in the chat to say how much of that I should go over and whether or not that's worthy of going over at all? Eric is typing, okay. Let's see, I guess I can. Oops. So we can even go and look at like Google's, for example, here, and click on your thing in there. Who has UC Davis's private key? Hopefully UC Davis's server. Which, fun fact, seems to be co-hosted by a couple other things. And might be, at least. Yeah, that was their site. So, I guess we can kind of go back to it here. The main part of RSA is that you have two prime numbers. They multiply to a public key n. And these are, of course, very large prime numbers, which make a even larger n. And this is the big part of the key. There's a also quite important part called E, which is another number. For almost everybody, that number is 65,535, which, if you're really familiar with your powers of 2, is a power of 2 minus 1. So it makes some math easy. And yeah, nearly everybody uses that one, and it doesn't reduce the security in any way, so you don't have to worry about that. But yeah, if you can factor that number here, you can impersonate UC Davis's server. But odds are, if you're like anybody sane and you don't have access to multiple of the world's biggest supercomputers, you aren't going to be factoring that anytime soon, because that's just a really big number, and that's a really hard problem for us to do with computers at the moment. But what we see about the certificate for ucdavis.edu is it is not actually for ucdavis.edu. It's got an alternate name here for 21stcentury.ucdavis.edu, but that also is got some information here about who issued it, how long it's valid, and a little bit about its fingerprint, so you can compare it easily, but we don't particularly care about that at the moment. But we don't just go and say it's issued by somebody and accept that, because otherwise we'd have some things that really start to cause problems. So when we get the page for ucdavis.edu, we don't just get UC Davis's certificate. UC Davis also sends us the certificate for the group that issued their certificate. In this case, this R3, which is part of Let's Encrypt, which we'll go into a little bit. But so this is getting out of hand. It seems there's more of them. Our certificates have certificates. What's the problem here? Eventually, are we gonna just trust this one? Well, actually, pretty much. We don't want to just go and trust that if I just go and give you my ID card and it says I am 12, that I am 12, or if I go and hand you my California ID and it just says I'm a card holder and it's got California written on there in crayon, I hope you wouldn't trust that that's real. And what you're looking for is some kind of signature on those IDs that says, look, it's actually California. It's got the fingerprint on it. It's got the bear thing with the star in it. It looks legitish. So you want to be able to have something on there that shows that it's from somebody that you trust, or it's trusted by somebody that you trust. So how this really works is that we go and trust a couple root certificate authorities. Let's Encrypt is one of the smaller root certificate authorities somehow still, but it's issued more than enough certificates and is in many, many browsers by now, and it's actually cross-signed by another root certificate authority, but that's a whole nother load of things. But yeah, Let's Encrypt has this main certificate that is really, really secured, but also its public keys given out to everybody. And in nearly every laptop and desktop around the world, you can go and find the public key for Let's Encrypt and these other main certificate authorities that underpin our web as a whole, that we trust to certify that websites are who they say they are. They delegate that websites are who they say they are job out to a couple intermediaries, such as R3 in this case for UC Davis. R3 here is a server of Let's Encrypt, I should say. It's not like this is some second company or organization. R3 is controlled completely by Let's Encrypt. But Let's Encrypt goes then in, or UC Davis asks nicely, hey, Let's Encrypt, can you please give me a certificate? We're going to look a little bit about how this is. But because R3 is signed UC Davis and Let's Encrypt has signed R3, and we trust Let's Encrypt, then we should trust that UC Davis is who they say they are when they provide us that key that's been signed as it is. So here are some of the big certificate authorities, such as DigiCert or GoDaddy, right? Let's Encrypt is on there. It's definitely not the biggest number on, or highest one on there. And what happens here is that they use their, or on this last slide here, they're using their private key to go and sign the public keys of the next one down, so that you can go and authenticate that this really was signed and authenticated and was done by that certificate owner. That is kind of a thing that follows from public key cryptography that isn't necessarily obvious, but I hope that you can trust me that you typically think of a key as having two operations, encrypt and decrypt, but there's actually four. Encrypt, decrypt, sign, and verify. And those require different key, or different ones of those require either the public or private key. To sign something with the private key, or encrypt with the public key, verify with the public key, and decrypt with the private key. And I got those in a very confusing order for you, but yeah. It's digitally signed by the certificate authority's private key, so you can be relatively confident that their certificate authority's private key is still private to them, but you know that happened and that you should trust it. So you can trust Mario Rossi of Wikimedia because somebody signed his public key that you trust. How do you get one of these things, though, you ask me? Well, you could pay money, and especially if you want fancy ones that go and say on there, like, it's not just a valid certificate, but this certificate was issued to Bank of America Corporation in the U.S. Because some people care about that, you know? I don't want to just know that this is a certificate to bankofamerica.com. I want the real Bank of America Corporation. And there are these things called extended validation SSL certificates that you can buy. They're expensive. And, well, we don't care about expensive. If you haven't noticed, I'm a college student, and I'm imagining here that you are too. If you aren't, I'm not sure what to tell you. Maybe you're cheap. Congrats. But I'm a college student. I don't want to spend money, so I'm not going to spend $100 and have some corporation thing so that they can verify who I really am. All I really want to do is verify that I'm the same server that checked in with that Let's Encrypt yesterday. Or 3 months ago in Let's Encrypt's case, up to. So Let's Encrypt does free non-profit certificate authority work, providing TLS certificates to 260 million websites. And, yeah. What do we need to do to get one of these certificates then? You need to have a domain such as cooldomain.com. No clue if that's actually bought yet. You might be able to. Get it while it's hot or something. But if you don't want to spend money, there's other options like cooldomain.ddns.net that don't require you to necessarily go and host that somewhere like GoDaddy or something else that costs money, because we're going the free route, you know? You then have to point it at a web server. You probably want that DDNS thing. Downbad.me. That's the cooldomain.com I actually want. Yeah, downbad.me. Is that actually a website yet, or? I don't know. I believe in you, Victor. Oh, you have it. Well, now I'll have to, attack it, or look at it. Look at it. And explore it. So yeah, you can go and point this at a web server. I'm gonna kind of hand wave over this, and yeah, GitHub Pages uses Let's Encrypt. They're very kind, and a lot of free web servers are like, oh, you want a Let's Encrypt certificate? Yeah, we don't have to pay money for that, but you have to pay money to us for us to do that. But GitHub Pages is smart and big brain and knows that it's very little work for them to provide security, and security is usually good. And yeah, web server, you can usually go and try to do it yourself, but I mean, most of us have public IPs that change every 24 hours ish. But maybe you're not on Comcast or whatever else ISPs that do that, and maybe you've got and you can use a DDNS if it changes, and it will go and dynamically update the domain name system. I don't think the Electronic Frontier Foundation uses Let's Encrypt exclusively or controls it in any way. I think it's co-opted by nearly every company and organization out there that isn't in the business of making certificates for profit. But I'm sure you can look at let'sencrypt.org and find out who owns them and runs that. But you probably are going to pay someone else to run your web server, or use something like GitHub Pages that goes and does mostly static hosting. Yeah, I don't know what tool you're talking about. Could you post more about it, I guess? There. But yes, certbot's the thing that's ran by Let's Encrypt, I believe, or works with Let's Encrypt and communicates with that server and goes and checks it out and says it's an interface for you as a programmer, sysadmin, or a random college student that just wants to host a resume site to go and say, Mr. Server, can I please have certificate? So this server will go and look at your website and say, wait a minute, you don't actually have this website that you say you do. You don't actually have a working website like you say you do. You don't actually own the DNS certificate like you might say that you are. Right? Huh, okay. More you know. EFSF's certbot is fair enough. Neato. But yeah, you can use certbot to do that. And, well, certbot verifies, because we want to trust kind of... Okay, no we don't. We don't want to trust at all. Don't trust. Verify. So, how do you get a certificate? And what are they actually checking? They're checking that the DNS records point to your IP address, and that you have access to that IP address at the correct port. So it's going to have you prove either by... certbot does pretty well with interfacing to most web server software and auto setting up a little page and then tearing it down immediately after. But you could also just go and have it up or put in a page and say well known and put in some little thing in there that kind of just says I own this. Or if you want to do really special, you could go and have a special DNS value set, and you can go and use that if you have if you can prove that you control the DNS records by setting a special DNS value. I believe it's, I forget the name of that type of record at the moment. But if you can set that kind of DNS value, then you can also get what's called a wildcard certificate. So instead of just being for a single domain or multiple domains, it could be for all subdomains. So instead of just an example here of cats.cooldomain.com, maybe I want to just have have my server be able to host any of my .cooldomain.com subdomains. So I'm going to get that wildcard certificate and make this pretty easy, which actually I think ends up being harder personally, but you do you, I guess. But hopefully here you've also paid a little bit of attention to what RSA does, and I guess these certificates that Let's Encrypt issues are typically RSA certificates, or RSA keys, and they're usually about 2048 bits, which is about the standard anymore. 1024 is bad, and 4096 or more is pretty slow, especially if you double by 2 again. Things just get really slow. So What options do we have, you say? RSA is slow and it doesn't actually provide all the encryption that you're looking for, because once you it lets you send your message to the server in theory, but RSA is not going to encrypt the server's message back to you. It does not have that ability. It can sign the server's message back to you and show that it was written by the server, but I'd really not like Bank of America to send my bank information back to me in a way that just says Bank of America wrote this, but anybody can read it. Otherwise, Bob, that's sitting outside my house monitoring my Wi-Fi, is going to look and say, oh, look, there's Mac's bank information. That's pretty neato. His social security's number is right there. That's pretty cool. Thanks, Bank of America. So what are we going to do? We're going to use something called Diffie-Hellman. Diffie-Hellman is no longer a public key cryptography system, but now it's a symmetric encryption system. So you're not just going to go encrypt one way or sort of one way with public key cryptography, but you're going to go and speed things up by using Diffie-Hellman to create a shared private key for the session, and then you can use whatever your favorite symmetric encryption algorithm is, because Diffie-Hellman kind of suffers the same speed things that RSA does. So there's other options like elliptic curve and Caa, literally dozens of these different options for how you can go and encrypt your stuff. Let's see. One of the great things about that also is that quite a few of those algorithms provide what's called forward secrecy. So even if down the road you go and find out that, wait a minute, Bank of America's key did get factored, that really doesn't change anything. Even if there was some server right next to Bank of America that recorded literally all of the transactions Bank of America had, with this forward secrecy, it should be possible to go and say that even if the HTTPS certificate was hacked, that initial RSA key was hacked, that you aren't really scared of anything still. You're safe. So, yay. But, of course, most of you aren't here for the defensive stuff and make your server nice and happy. We are looking at how can we break things. Because, I mean, let's face it, it's much more fun to explode a house than to build one. You know? So, what things can we look at that go and make this extra sketchy? Right, so you can go and sit outside a Starbucks with your Wi-Fi pineapple device there, and you can just go and listen for that Wi-Fi traffic and just hope that a couple of those packets happen to be on HTTP. I mean, it works. It at least technically does, at least. There definitely are those people that manage to just be like, oh yeah, I'm just going to listen for Wi-Fi traffic and hope. But that's not always sane. You can look for really stupid sites like this interactive brokers screenshot. I tried to verify this outside of the Twitter post that Kevin had sent in there a while back. It's like, oh, turn on or off SSL. And I guess the silly thing to mention, SSL bad, it's old, it's bad, don't. What you want is TLS, transport layer security. But that's another whole sketchy part to saying turn on or off SSL, is that SSL should be off. Or you could just hope that they're using old out-of-date software like your Windows 7 Professional, and that does not support the latest encryption standards that we have, and maybe that means that they're still also maybe using Windows XP on those servers, like what Fry's Electronics used to until they went out of business. Rip Fry's. Right, their store servers or store computers were all running like Windows XP or worse. Right, and you can just go and think that, wait a minute, maybe they aren't going to be using the latest encryption standards, which means I might just be able to decipher that a lot easier than if I was trying to listen to those new iPhone XXs or whatever. I butchered whatever. The latest iPhone or Android phone or laptop that hopefully has all its updates, and with all those updates comes the actual updates to those encryption algorithms. So, get those updates so that you can actually have good encryption, hopefully. hopefully. The other, and what those people are doing with like your Wi-Fi pineapple here, that's just listening on all these different Wi-Fi channels, it's going and trying to be a man in the middle. It's going to go and stick in between you and the server that you're trying to contact, or your client, I guess, if you're trying to be a server still in this imaginary situation, and it's trying to listen to it and eavesdrop, or go and get in the middle of this conversation and pretend that it's the other party for both ends. Right? It's not all that hard to just go and say that, oh, I'm going to listen to the Wi-Fi, or I'm going to, somewhere in between these two people, pretend to be both and say, oh yes, client, I'm your server, really, I promise. Oh yes, server, I'm a client, really, I promise. But luckily, we can verify that that person in the middle is not who they, or is not the server, right? And we can go and verify that with that secrecy, that we aren't going to go and give people information that they aren't, or that they aren't supposed to get. Right? So some of the main vectors of those kind of attacks still, though, are DNS, the domain name system. How do I know where to go when I say bankofamerica.com? So you could go and make sure to set trusted DNS servers instead of whatever your ISP does. Because odds are, if you're using your Comcast router still, that your Comcast router goes and sets the DNS servers used by your entire network. So you could go and say that I'd really not rather use Comcast DNS servers, or DNS servers that are set by Sketchy Coffee Shop Incorporated, right? I'd rather set it to Google or Cloudflare or whatever else. And with those, you can also go and have the security that might come with using DNSSEC or DNS over HTTPS/TLS, which are oddly confusing standards that may or may not actually protect you in any shape or form. You could also try to obscure part of the path between the client and the server, which might help you if you're in the middle of that Starbucks and you don't want to trust that there's nobody out there listening to your conversations. You can go and proxy it over an SSH connection or whatever proxy you might find on the internet, or a VPN that you can go and find a YouTube ad for at your leisure, or the Tor network and really feel like a hacker or something. But there's a little problem with that, is that you're always trusting that the end of that connection, the last step between the server and your exit node or VPN server or proxy server, is legit. The dark web, yes. You can use your Tors on the dark web. The onion routers. Some other cool things that go and prevent your your man in the middles, is what's called HSTS. Strict Transport Security, I believe is the correct name of that abbreviation. And what that does is it just caches the key in the client and will say, oh, you're not the key that you were last week. And that's on one hand very good, because maybe somehow you got a legitimate looking certificate for my server, but I, as the client, know that, wait a minute, I connected to this certificate last week, not that one. That one's bad. No. But there's a little bitty problem that, what if that actually is you? In which case your users are fucked. Because your users are not going to go around this big scary alert saying, this is not the server they say they are. So that one isn't really used that often, but it at least sort of adds some security-ish. There's things called Caa records, and if any of you want to go and look up a Caa record, it is a certificate authority authorization. And what that does is it means that hopefully your certificate authorities, before issuing a certificate, will check for this. And this just goes and says, only Let's Encrypt can issue certificates for bankofamerica.com. Or only DigiKey or GoDaddy can issue certificates. Which is hopefully a good thing, right? If I only get my certificates off Let's Encrypt, there's no reason that anybody should ever issue a certificate for something not using Let's Encrypt, right? I'm not gonna buy one from Let's Encrypt, or not buy one from Let's Encrypt and get one from somewhere else. You can also, actually use HTTPS, as we've kind of been going over. So what you do, you just go and look for those, or still listen for HTTP requests, but you go and, how do you serve the certificate? You give away your public key, and then with that public key, you're also giving away the signature provided by the certificate authority. Yes, your web servers typically handle that for you, and if that's something that you're interested in, I can point you in the right direction for that. I could even show you, I guess, the configuration file for what I'm using Apache for our club website. So I don't have Nginx thing there set, for example. Kevin Wong might still have an example of that maybe, but that seems like work on him. And realistically, if you're using Certbot, Certbot's going to handle that for you, which is really, really nice. Because, I don't want to have to do any of that crap. And I'm probably not as good as Certbot is securing my server. Go figure, who'd have thunk, I mean, look at it afterwards. Don't just blindly trust that the program that you downloaded is correct. But, you can have some trust that they know what they're doing better than you might. But what you need to do, you need to keep your private key as your server's private key private. You don't just go and give it out to another person who might want to man in the middle you. You keep your server software securely updated, and you don't just go and let it be on the very, very last thing. And you revoke it if you lose your security. So if you think that somebody hacked your web server, you aren't just like, oh, I'll get a new one, I guess. Because your old one still is valid until it expires, which, if it's Let's Encrypt, might just be a couple months. But if it's another one, it might be a year or more until that. So if you go and lose the security of your certificate, you go and send something to Let's Encrypt saying, hey, I had the private key, but I might have shared it. Pretty please, go and issue a thing saying this certificate's no longer good. Which is fine and easy enough to do, but realistically, if you want to attack things, the better way is probably still go for the server, or you should have gone for the server, not going for the client, not going for the TCP connection, not trying to go and sit in Starbucks and hoping that somebody might just go and send the right packet over, because, well, one, how many people are in Starbucks at the moment? Welcome to COVID. But two, the server has many more users than the Starbucks, And yeah, you have a much better chance at finding one bad server than in whatever server that you check versus one, or looking through all the crap that clients are doing in a Starbucks and having that be helpful. I did upload the log for the CyberSec server for today, and that's in the Google Drive folder if you want to take a peek at that. And I will here at the end. I think I have I have 2 slides left, and then I will take a peek at that one and explain a little bit about what that logs and see. But mostly what our server log is, it's not like most of us are going on there and refreshing that page all the time. Most of those are bots scanning the web with a list of vulnerabilities and saying, is the WordPress login default? Let's find out. And just scanning the web for all that crap. So, it's pretty easy to just go and scan for simple server-side vulnerabilities like that and look for those WordPress things. This same kind of key security sharing thing translates over to other security things with keys. It doesn't really work with SSH, because with SSH, your SSH key is going to be trusted, and you aren't going to typically allow or go and sign your buddy's key and be like, hey server, here's my buddy's key that I signed. Or not like that, but your buddies can't be like, oh, Bob signed my key, therefore, and Bob has access, therefore let me in. That usually is not a good security idea, so that isn't a good option. But what you might do is PGP, pretty good privacy, is a email encryption method for the extra, not extra obsessed. I'll go with that. And you can go and extra encrypt your emails, end to end fully, not just through Google and transport layer security. Because I mean, Google reads your emails, right? But I don't want Google to read my emails, so instead I might use PGP. Fun fact, Facebook does, if you somehow want to give away part of your data, but not all of it. You can use PGP emails from Facebook. Don't know how great of an idea that is, but you can go and trust somebody else's key and then use that trust in, or you can say that you trust that somebody else's key and share that to somebody else that trusts you, and hopefully then if you're at B or C, you can establish some trust that B and C are who they say they are, because A is said so. And another cool thing that goes along with HTTPS, and this one actually I really love the idea of, is something that Stanford does, and they do what they call cardinal key. And instead of using a passworded system like our Kerbos, which is, it's okay. I mean, you know your password hopefully, and you know that you only put it in on the right 2 sites that look sort of legit, and that's good. It works, but you know, that's not perfect. I mean, I can still try to fish out that key from, or that password from you, and give you a UC Davis login looking site. So what options do you have? You can use what Stanford calls their cardinal key, or the ultimate in passwordless login, and Stanford issues keys to their students' computers and their staff, of course, and those keys live in their computers, and then when you go to a site, specifically Stanford sites, Stanford will go and check and interact with that key and verify not just that they are who, to you, that they are who they say they are, but that you are who you say you are, without ever having to type in a password except like every 9 months or something silly like that. Which is really a neat idea, honestly. I mean, yeah, it would suck if you accidentally jumped into a river you were on your way to school and you drove your car into a lake, and now your laptop and phone are both waterlogged and ruined. You can't just go in and sign in with a password as easily. But, you know, honestly, there aren't too many students who are jumping into rivers with their laptop and phone. Unless that's one of your hobbies, in which case I don't judge. I judge. So, yeah, that was most of my talk. I'm going to go over the log too, I guess, but if there's any questions, start saying them, or typing them, or keep typing them, I guess. I'm going to open up the log and look at that a little bit, but it's not all that interesting, honestly. And we can also, let's see here, also look at Wireshark a little bit, and the captures that I uploaded, so I'll share my screen again. Oh, no, bad. Let's see, this one. So this one is the log for our I run the server on Apache. This is the log just for today. What the format of this one, this is what's called a virtual host log. It's not a simple Apache log. Starts off with the server, the port. Notice that a lot of these are sent to port 80, which is your HTTP request. But there's also some that are sent to HTTPS and are looking for something. And some of these actually might be legit-ish, right? Maybe somebody actually was trying to get the correct server. But you never know, really. So there's all these different things. I mean, robots.txt might be legit, or blog.robots.txt might be legit. But the person going here for WordPress or WP, they're trying to poke at us, you know? And if I was sane, I would go and say in there that, wait a minute, I don't want that to be somebody I let ping me twice. So I should go and say, oh, you tried to access WordPress? No, no, no. We're just going to ban you. And there are things like fail to ban. That's a program that just looks and says, "Oh, you failed to log in once? F you. Congrats, you're banned from our server for 24 hours." Or you tried to nmap us? F you. You're banned from our server for 24 hours. But that seems like work, so I haven't done it. Let's see. There's a lot of other things in here that are definitely also obviously attacks of some kind. Right, I mean, some of these are saying, some of these are like, oh yeah, that definitely sounds sketchy. Because I can just tell you that's not a file on our server and it never has been. But somebody's trying to find a evaluate standard in.php, and if that doesn't scream remote code execution abilities to you, it should. But they're looking for it, so thanks to 45.155.205.181 in whatever country they may or may not be from. And some of these are legit. I mean, this one here, like, this is looking hopefully for a verification of site ownership or something along those lines. The favicon icon that goes and shows up and makes your tab indicators look pretty. Oh, somebody tried to just go and scan us that way, which, I mean, I guess that works. Python request and look at what we're doing. Oh, I forgot to look at chat again. Sorry. That should be kept in mind. Yeah, these are bots and fishing around all the time. That's another kind of fun one. And it also logs things like the response code, the user agent. Yeah. Let's see. Stop screen. Yeah, it's not a reason to freak out and say your site's under attack, which, I mean, it is. Yeah, not any more than normal. This is the default level of attack now that somebody knows that I'm hosting something. And this has a lot more than, let's say, my resume site that's hosted on the same server does, just because this one's the default. So if they just ping the IP, it will go to this virtual host, which is an interesting idea, I guess. And I think one of them went and pinged, not, I saw one of these had pinged through .tk. Yeah, this person here this was the only request in there that actually had reached us, it seems, through the other name for the site, .tk, instead of the ddns site version. It's the same computer, same config file, but it changes a little bit of what's going on. Or, sorry, it doesn't change anything of what's going on. It's just that, yeah, this person sort of knew what they were looking for, but quite a few of these are just looking by IP address and scanning for things that they don't even know whether or not they exist or not. Right? Most of these are just looking for, let's see, I guess I can filter it that way. Oh, actually less than I thought, I guess. I mean, still not great, I guess, but, and those are close enough that, oh, and I didn't even notice that, like, this one, all of these are from the same server, right? So something like failed to ban would have been nice to just go and say, I'm not even going to interact with you anymore. Because why should I have my server waste its time sending 404s back to them? Right? It's not like this is in any way legit to start a debug session with PHP Storm, right? Or auto-discover, whatever they're trying to auto-discover or evaluate standard in. This person just has some script that's running and checking for all sorts of crap. So, yeah, fun. Alright, well, that's pretty much what I had for today. What kind of questions can I answer or not answer? Avoid? Can do my best politician and avoid all questions, or avoid questions I don't want to answer. Don't worry about it. Ask questions. Or don't. It's up to you, I guess. but thank you for coming. Where do I find the logs? This log specifically, I uploaded to the last Google Drive link I put in. I'll put the link in the chat again here. And at that URL, you should be able to, I will screen share again. WebSec talk folder thing that I made. It's called File, so very helpfully. And Google won't preview it, of course, because I named it File, which is annoying. Oh, where is this on Linux? These are mostly found in varlog. For this one specifically, it was found in varlog, Apache, other vhost logs, and I can pull that up, but yeah, I'll pull that up. So hopefully if you look in your own var log, you have something along these lines. To be honest, I probably have way too many things running, but you can see that like Let's Encrypt has a folder here that goes and stores its own logs, but Apache 2 right there is the main one that we care about right now. And it's got all sorts of different error logs and access logs. The access log is going to be empty, mostly because everything is running as a vhost right now. So I can go and cat other vhost access log, and it gives you all the things that pretty much have been there. Outside of the ones I didn't show were the ones that are sent to my own personal resume site kind of thing. Let's see, what have you got? May 2nd kitty box. Oh, your SSH. Okay, so SSHD is your SSH daemon. Connection close. Wait, what log is this? Yeah. I mean, yeah, logs like that definitely exist. Your SSH daemon will log things like that. Let's see. Do I have that specific? I don't see that one there at the moment. That's actually kind of worrying. Where's my... Yeah. Oh, offlog. Yeah, that's fair. And yeah, I've got pretty much the similar idea that it's going and looking at your mostly SSH things, but also a couple like cron jobs. Yep, that's a fair point, Arnon, that, yeah, Apache is root and will log to wherever your package manager decides should be its default, and it's not really Apache's fault, I guess. But yeah, when you have logs like this, or maybe not logs like this was only 100 lines at most, but when you have bigger logs, this is definitely where things like grep come into play, and you might want to go and grep for things and say, well, wait a minute, I really don't like it when people are, I want to know what IP addresses keep attacking me or whatnot. Right, so you might go and just grep for things and grep for things, or use awk if you're a masochist, or regular expressions if you really hate yourself. I mean, if you're really, great at what you do, and great at what you do, and actually know more about how to use these things. Yeah. when there's more lines to these, especially if you're looking for bigger servers, you're going to want to have more skills to not just scroll through it mindlessly. Because, I mean, you have no idea what a valid log is. Valid log, is that something that I should be thinking of here? Or is that what a valid log in... Oh. I mean, hopefully all of your things there are valid logins, right? Or I guess none of those seem to be. That's a little concerning. But I mean, hopefully you could just go and, if you have SSH, you should be able to SSH into yourself and find the last line on there and say, yep, there's my IP address. Yeah. So yeah, today was a relatively short talk. I'd love to hear what you'd be interested in for a future talk. I don't know necessarily if I'd be able to give it next week, but tell me. Oh yeah, new session of User Ashley. Ta-da. Yep, setting your home directory thing and yep, getting through the firewall to, yeah, makes sense. We'd be glad to have you.